Hello and welcome to Live Coding with Gerph. Hopefully, there we go. A little bit more of me this time. Since we're doing a Q&A, I'm going to leave this with little bits on here. So we've got, this is my top left monitor. This is, I'm pointing to the wrong things, you can't see them. Yeah, you can't see where my pointer is. Top right is my top left monitor, and top right is the top right, middle right is the middle right monitor, and this is me. Yay! Yeah, sorry, you can be looking at me if I'm not coding. Of course, we can pop to here and we can do coding in this window, and we can pop to here and we can do looking at web things, and then we can move back to being full screen. I'm just playing with the video settings basically, but it's turning out quite nicely so far. Right, anyway. So today is intended to be just a Q&A session, and any sort of coding we fancy doing we will do, but mainly just the Q&A, and I haven't got very many Q&As, so it's going to be a relatively short what do we call it, session. We'll see how we go, and if there's any questions people have, feel free to just post them on the chat, and hopefully we'll be able to answer some of them, I hope. That's the idea anyway. We'll see whether it works out. I've got a few questions that people have submitted. Excuse me, I'm just tired now and things. I know I'm tired all the time, I realize that, but yeah. Okay, so let's start out with one of the questions that was submitted, which was why are you doing YouTube and do you enjoy doing it? Which is relatively easy to answer. The handling of presentations has never been my strong point, so I've enjoyed doing the YouTube things. I've enjoyed doing the presentations to Rogel and to others, just like try and spend some time enjoying the things that I do like talking about and improve my skills. And doing the live coding has been pretty fun because it's been a chance to like show that you can do things, show that I can do things, which is always useful, and to try and give people an opportunity to see how I do stuff, hopefully so that they see that I make mistakes and that although I think I do pretty well at these things, it's all a matter of what you're trying to do. There's a lot of opportunities to learn about things for myself and for other people, and also to hear other people make suggestions and point things out that I've missed, which is also quite fun. We've got a few questions coming in. This is good. So I'll be looking through these and making sure we answer them. So yes, I do like it. I enjoy it. Is it the right forum for it? I don't know. So obviously YouTube is like one of the most accessible platforms because it's free and because it's basically on every browser and you have apps for it everywhere. I know other people use I'm trying to remember what it's called, Twitch. But that's largely for gaming, and I didn't really want to be dumping myself into there. I don't know where generally coders do things. I have seen some videos of coders doing live coding, and it's been interesting. Yeah, it's not like well, yeah. Somebody says, "Well, not on RISC OS, it ain't." Well, that's tough. I mean, you have to cope with the limitations of your systems, but I assume that all users will have another system to be able to use things, so that they can do stuff. If they haven't, then, well, that is just something you're having to do soon. Oh, somebody asked me about doing the captioning. So you should have captions on this. I believe I've enabled captioning, so you should be able to see it. Closed captions not enabled. Huh. Well, that's irritating. I thought I had that enabled. I can't edit the settings here. Well, that's messed that up. Well, maybe we'll do something later and get a stream, a transcript generator or something. Yeah, it's very strange. I thought I had the captions on there. What does contrast do? Yeah. Ooh, set up overlays for your breaks. Oh, I didn't know I could do that. I'd do it all myself. Oh, yeah. Fair enough. Anyway, so apologies. Apparently I don't get captions. I will try and sort out something for that, since that's now been mentioned and needs to be handled. I'm trying to make it as accessible to people as possible. I mean, that's why I've tried to make it at a reasonably sensible time on a weekend so that people can see things. Yes, I do have hard of hearing viewers, so yes, I'm trying to. I genuinely thought I had closed captions enabled on this. It might be it turned off when we went to low latency, but I don't think I can change any of those settings right now. No, it doesn't let me do that on here. I can only change the metadata about it. Some ratings, licensing, customization. Oh well, yeah, so I'll produce some later that hopefully will help. So yeah, that's the why I'm doing it and whether I enjoy it and stuff. I'm just looking at that 64 logo. It's not. I'm not so keen on that 64 logo now. It's looking a little bit ugly. Let me just. Not sure that's any better. I'm turning the glow off. Yeah, well, oh no, I don't know. We'll leave it on. It's fine. Glow and turn it off. Whee. Nah, I don't know which is better. So yeah, that's the why I'm doing the YouTube. It's also hopefully a way to promote things outside of the usual community. If people have been here a little while, they'll have seen occasionally we get drop-ins from random people all over the world that have come across it. So yeah, that's one of the parts that hopefully it surfaces it to people. Yeah. There's a number of questions that are more technical, and there's some that are less technical, and there's also some that I've got that are relatively easy to handle. So I'm going to try to kind of answer the easy to handle ones first, because that's probably the simplest way to try and resolve those questions, because we can get through those and look at the more technical ones if we need to. So simplest things I can answer in sort of the same way. So for my 64-bit work, this is largely for my stuff and the way that I'm doing it. I'm looking at my list of things over here. Let me move it. Oh, I can't move it over easily. It's fine. I'll leave it there. So for my 64-bit work, it's largely trying to make 32-bit version, 64-bit version, which works in pretty much the same way, and which we can compile and use on 32-bit, and we can use on 64-bit as well. So that's the sort of goal of where I'm going. So this will sort of help answer the next set of questions, which is what hardware platforms are your primary targets? I have no hardware platforms I'm targeting. I am just targeting converting the components over to be 64-bit. Hardware implementation should be handled by somebody else who knows hardware better. Basically, RISC OS is modular, so you should be able to just easily plumb in the hardware implementations of things because of course all of your hardware that you've got implemented is written in C these days, because that's the way things have been worked on, surely. And they should be relatively easy to plumb in, but that's a problem for somebody else to handle, because I'm not doing that, at least not initially. There's enough to do on the rest of the system. Hardware is a unimportant part of it, because it's just the lowest level. The rest of the operating system is significantly larger, and therefore is a bigger deal, whereas the hardware is specific to individual platforms and whatever. So that's the reason I'm not targeting any hardware. So other question is, will dynamic areas and application memory handling change significantly? Nope. They'll be exactly the same, because I'm not changing any interfaces. I'm trying to keep them as close as possible to the originals, so that we're not worrying about anything being difficult to translate. Basically, you should be able to, if you can just compile your code in 32 bits, then hopefully with just the types changed and possibly a few other bits and pieces, you'll be able to build the 64-bit as well. That's the intent. So I'm not planning on changing any of that. And the follow on from that, which is any plans to modernize memory protection or process isolation? No. Everything's going to try and stay the same. The closer we keep it, the more likely it is that you get things migrated over. There are obviously reasons to upgrade that, and particularly for process isolation, I think there might be some ways of doing that, but it needs to be thought about in a structured way. Largely, making the rest of the system work is going to be the bigger task. And if you change more of those components, you end up not breaking things, but making it more difficult to get people to migrate over. That's the real issue with it, is if you have a system that doesn't... Yep. Sorry, I didn't see you there. I've got my cup of tea. If you don't have I don't know what I was saying there. I've lost myself. My cup of tea has confused me. Thank you very much. Nice cup of tea. Start my break. No, I don't want to start my break. I want the break to stop bothering me. There we go. Right. Yeah. So yeah, those parts are the 64 bits doesn't introduce those things, and the same goes for what enhancements would you expect to introduce? Nothing. So I don't intend to introduce anything extra as part of the 64-bit work. That might happen anyway as part of other things, but enhancements to the system are enhancements to the system, so bring them in as you come. People can add those as they wish to, but if you try just only attacking parts of the system that are the same, then you're more likely to succeed. If you go and change more things as you go, it's more likely that something's going to go wrong, that you can't port things over easily. I mean, it's already becoming difficult on things. So trying to make things more accessible to the people that are actually developing things means that it's going to be useful for them to do stuff. I mean, that's the reason why. So I ported RT Russell's BASIC and then made it handle BBC Basic style tokens. And the reason for that is because by having those tokens, we have tokens being able to be processed. All the BASIC that we've got existing should be able to start running. We can start running tests in that. We can start running small applications. Maybe we can start throwing Yan Vibes things at it. All of the other little programs and tools can run. And that exercises the system. And then we have a canned audience that can start to use it, even if it's not like in anger or anything. Developers can start to use it. General users can have a play with these things, because it's complicated and you need to have people testing it and trying to use it. And to make that as easy as possible, that's what we try and do. Same goes for the build environment. The build environment is intended to be used in basically the same way as you did the RISC OS environments. So the RISC OS Classic file layout and so on. So your code just compiles. It literally just compiles as is. You don't have any hassles with that. That's the intent anyway. If that doesn't work, then that doesn't work. But generally, that should be relatively easy to make work. And the closer you are to the original classic system and the way that the build environment works and the tooling works and the writing code works, there's no extra learning about it other than the very, very small, hopefully small, API differences that are just going to be necessary. So, for example, I've chosen to drop flag returns. So the only flag that's returned is the V flag to say there's an error. Everything else is just no, you return it as a plain interface, which then means that it's a lot easier to access, because you access the interface that is the registers rather than the what are they called? The flags. Processor flags might not be implemented on some systems. I mean, we've got 4 processor flags. There's the NVC, Z flags, and there's also the other ones as well, the Q, and there's another one, I think. But the point is that those flags are not necessarily present on other systems. So if we remove them from part of the interface, then it becomes a much less difficult thing to port to other systems, because yes, I ported to ARC64 in Pyromaniac, but what if you want to make things work in x64 or EMD64 if you're using those terminology, x86 64 if you're using that terminology, because there's enough. Or you could have RISC-V, or we could compile for MIPS. One of the 68,000 variants. It being in higher level language means you've got the choices. So that's the point anyway. But the more in high level languages, the better. So that's the why and the how I'm trying to do this. Yeah, I hope that answers those questions as well. There is a follow-on to those that I'm going to just bundle into there, which is quite interesting. So, will the system support both 32-bit and 64-bit applications? And if so, what compatibility strategies can be considered? So, this follows on directly, because if the interface, the API differences are next to 0, or small enough that you can just do a small tweak on pass-through, you just have 32-bit stuff running in the system exactly the same. And everything just works because it's being passed through 32-bit registers with 32-bit address space using the same SWI APIs, and everything just keeps working. So that's why, that's another reason why keeping to that structure is important, is useful to me. Do I intend to do that? No. So I've had some ideas about how to do that, but ARM chips with 32-bit support won't be around forever, so there's going to need to be an emulation solution if you want to go through that route. Or there may be a way to do the calling down to the 32-bit environment if the chip does support 32-bit. And again, that's something that the hardware implementer can handle. All that's important about the work that's being done is that you not preclude that from working. So, for example, all of the binaries are labeled as being what the architecture is. So they're labeled as 26-bit. You know that. We know we've got 32-bit ones. There's now 64-bit labeling on applications, absolute files that is, and on utility files. Modules have also got the same thing. So they've got flagging to indicate what architecture they're running in. And of course, the interfaces should be exactly the same. The only time it'll matter is when you're trying to call between things. So for example, if you're trying to set up a callback to a 32-bit module from a 64-bit module, that's going to have to be something that somebody will think about. I'm not addressing that immediately because I'm trying to keep everything just the same. It's a 64-bit system. But that'll be something that we need to be thought about. I am not immediately thinking on that. So that answers a few of the questions that have come in by email. I'm just going to check my phone, see if there's any others that have come in by email. Lost my email. Yeah, there we go. No other questions so far. Yeah, we'll come back to that one later. So yes, those are some of the main questions, not some of the main questions, some of the questions that have been answered there. I'll come back to some of those ones that have been emailed in. We've got 3 questions down here. A technical one about vectors, reasonably technical one in implementation about how to handle porting things over, and a general one about how to stop feeling overwhelmed. So let's have a general one first. Let's answer that one, and then we'll come into the technical ones. So how do I stop myself from feeling overwhelmed by the size of the project? Breaking it down to small parts. So the way that we've got this structured, if you have a look over here, is by different phases. So each part of this is able to be, this is something I can target. I can look at something in. So if we have a look in here in the initial part, so this is the sections that we've got done. We've got a lot of components here, and not only are they focusing on breaking down into components, but also sometimes they're just saying, right, we'll only get as far as a prototype. We'll only get this one as far as being a stub. And that's what do I need to make it feel like we're making progress and move things on, both for myself and to the community. That is one of the ways of handling that. Now, obviously, there's a lot more than just these components. There's all the build system, build environments, and there's the ROM running and things like that. And those are just things that will be ticking along in the background as well. But largely that's how I do it. I look at individual parts and I try and make them work. And then it's very important to me personally to have these sorts of tick lists that show I have succeeded in doing this. This is what I have done. This is how far I've got. I've not quite got it finished there, not got it finished there. The reason for that is vectors, and we'll come back to that because that was part of the other questions. This one hasn't gone very far, and the reason for that is because it's hit the case where we have to handle configure commands, and configure commands are a little bit more tricky. So that's why that one's a bit more difficult. It might hang around for a while, that one. So same goes for this one's vectors. So largely this is all completed in phase 1. Phase 2 here, breaking things down. Again, these phases were, when I started thinking about it, I started thinking about what was the conceptual areas that we actually needed to handle. So let me just go back to here. This is what it is. I wanted some simple modules and stubs, then I wanted to start advancing the functionality, then start wiring things up, then starting to get some of the desktop together, wiring in some hardware, some printer bits. Printer bits are really complicated because of the redirections and all the vector handling and everything. And they've not been particularly given a lot of love over the years. So they're quite a bit more difficult. And then finally moving on to applications and then doing some compatibility things, which might include the 32-bit, 64-bit management. So that's the how I thought about it whilst I was trying to set these up. I also thought about what are the particular areas that we actually do things. So this is the audio stack, and this is what you can expect in each phase. So in phase 2, we expect to have a reasonable degree of things starting to come together, and by phase 3, you've got some actual functional things. By 5, it takes you to stage 5 when we talk about the hardware, because I'm not expecting hardware to come in until later, because hardware's hard. Compatibility components are all pushed to the end because they don't really matter that much. Core components should be coming in earlier, but some of them are less required. So zlib and zipper, they're core, but they're not really required, if you see what I mean. They're core to other parts of the system, because zlib's needed for other things, so it can come in a bit later. And then the desktop, again, we're aiming for phase 4, but we need to get some bits done early on to try and get the foundations there before we start proper work on the WIMP. Now, as you can see, there's some bits here like the icon rendering and text rendering and stuff that we've got working a bit sooner, and that's largely because, although this is what I planned, there's a social requirements as well, social and PR, if you like. So doing live coding on things that are just code is a lot less interesting and a lot less likely to bring people in. So I've sort of started to push those in a bit earlier on than where I had intended them to be. So text rendering was meant to be in phase 3. We've nearly got it done. Tiling is nearly completed as well. Same goes for that. So there's bits and pieces that have been pulled further towards the front for that. And again, this phase 4 is actually quite large and probably should be split up into maybe 4A, 4B. I need to think on that as we come towards it. But that's the sort of the ideas of that. Filing system. Again, this needs to come in a little bit earlier so we can actually get things working, but Pyromaniac takes away a lot of the need for that. So there's some bits there that are needed earlier than you might think. And then the graphics system, so all the conversion stuff can go right to the end. It doesn't matter. But things like getting draw working needs to come in a bit sooner. Some of the work on that has been done and the like. There's also bits that haven't been broken down, so the VGU system perhaps should be in here as well, and it's not listed. I think unless it's in core. Is it in core? No, we don't have in core. So there's some bits there that are in need of work and need to come a bit sooner. I was on graphics, wasn't I? Sorry, here. But again, modes handling needs to come in here, and it could be delayed until there because you could just work with Pyromaniac, but then we need to start bringing some of those things in a bit later. Again, this phase here, phase 5, is a little bit full as well. So some of these later stages are less well focused, and so they need to be expanded. And then here, hardware, as I say, mostly deferred to phase 5, and some of it's like just we'll not even plan anything. We'll just leave the investigation until later. So the answer to the question really is break things down, try and bring a way of managing the expectations that people have so that they're going to be able to see something but not a huge amount, but they are seeing progress. Make sure that it's something that can be broken down and that other people can pick them up. So if somebody wants to write one of these components, they can. If they want to use one of the bits that has already been developed. So I don't know if people have seen the OSWise repository. Not OSWise, OSLib repository. That's got a whole bunch of stub components that basically just build the module's SWI interface and just do nothing with it, but the SWI interface is there and documented, and you can start filling in parts of it, even just like it just return fake values just so you've got a stub there if you wanted. Hi Rob, it's Rob Andrews from Australia, apparently down under. Yeah, Been chatting to Rob quite a bit, been chatting to Andrew quite a bit, been chatting to Alan on and off, and Martin's obviously been around quite a bit as well. I don't know if we've got a Dave here, but he's usually around. He's probably busy today. He was painting the bathroom, I think, last week. But we'll also have other people. Hello to everybody who's here. Internationalization, some bits should come early, some bits need to go later. So that's IO. Internationalization is tiny, sorry, those bits. Don't have territory manager in there. Territory manager should be in there, shouldn't it? That's odd. Yeah. Maybe I put it in a different area. Maybe it should be moved from, maybe international keyboard should be moved into there. Don't know. But these are, again, early-ish things, so we can get them working. Territory manager, Rule had stated in one of their presentations that they had completed, but I've not had any input from them about it, and it's not on their repository. So not being very helpful there to get any input into that, because territory manager would be another useful core component to be able to pull in. Here we are. Here's some of the kernel components. They've actually been split out into kernel. Maybe they should be brought into other areas. So maybe VDU should move into the graphics section or something. Kernel graphics certainly should. So there's some bits here that have not been managed properly. But this is a different view to the phased view. And this was largely created so that I could see, am I front loading things? Am I back loading things? Am I going to find myself overwhelmed when I come to stage 3 because I've put too much in there? Or am I, if I start thinking about just the IO stack, is it all in one area? Do we have to put everything all at the beginning, or can we move it a bit later on? So that's the sort of thinking and planning that I've got about this. I mean, we can also put, if we wanted, we could put together a little Gantt charts that actually showed where things would go, but I didn't want to do too much. I mean, this is actually structured as a Gantt chart that just doesn't happen to have any dependencies on it. It's just showing individual items. Excuse me. So yeah, there's printing, and then there's some reporting. So this log's finished. Whee! Because it just compiled and worked. I've marked it as complete. Doesn't mean, yeah, it's completed pretty much. And then we've got other sections here, like toolbox, which is just like, whoa, move that right to the end. We don't care. It's all in C, and it should be largely just compile it, get your types right, and it just works. I'd hope. Again, that's backloaded all of that into phase 6, but it's about the only thing in phase 6, so we don't have a lot else in phase 6. Yeah, graphic stack, fair enough, but those are largely just compile them. Some more desktop things, drag a sprite and the like, nasty. But yeah, so that's, I hope that has answered in a vague way how I managed to not be overwhelmed by it. It's just keep going at things and keep plugging at them. Oh, there is one other thing that's useful in this, and that is RISC OS. Come on, can I type please? RISC OS open announcements. Let's put it in there. That's what I want. Oh, except it's not in there. It's in the 64-bit section because it's 64-bit work. So my regular updates on this status of the updates here, this produces a overview of where we are and where we've got to in the last month. And every time we get to the end of a month, I look at it and I go, oh my gosh, I haven't done very much. And then I go and start writing the list of things that have happened and work through the so I work through what's on GitHub, I work through what's on my local repository, I work through what I've done on the build system, I go and ask my wife what else I've done. If I haven't mentioned it, she'll almost certainly mention, oh, you've done this, that and the other, or did you mention such and such a person was doing things? Like, okay, yeah, I'll put those in as well, I forgot about that. So this list becomes larger. and it gives us a chance to see what's going on. So we've got down here in the other things sections, we've got the stuff that's come from Piers that he's doing for the printer drivers, which makes for somebody else actually working on things. Yay! I think that's very important, but it's important to show people that there is stuff going on and that it's not just me, that there's other things happening elsewhere. So that's what I'm trying to do to both stop myself from feeling overwhelmed and from communicating what is going on, to give people a real feel for there are things happening. It is real progress. You won't be seeing it because unless you're a developer or you're actually looking into this stuff yourself, you're not going to be following it. But you will be able to see these percentages. Yeah. These percentages going up. I did wonder if maybe I should have a little graph that shows progress over time so you can actually see us getting through things. But oddly enough, I only have so many hours in the day, and I have to commit some of those to work, real work, my actual job that pays money, because that's useful. Some of the time to this, some of the time to the house, and some of the time to Talia. And Talia takes a lot of time because we're married. And I don't want to be excluding her. So she is very, very supportive, and she gives me a lot of time to do things, but that is also reciprocated by my making sure I spend time with her and we do things together. So that is how my days break down, and how I stay sane as well, because it's kind of fun to be able to do some of these things. That also feeds into my first question, which was the why are you doing YouTube and like. It's part of the live coding in particular is part of the relax and just do something that's a bit fun, and it obviously produces real work as well. So yeah, long answer to that. How do I feel overwhelmed? And I hope I'm bringing in some of the other questions as well as supporting evidence, or yeah, just they dovetail into one another, I hope. What other questions have we got? So yes, so there was a question that came in by email, which was does follow on from that. Would you like to see more open collaboration around parts of the project? Yes, please. People, work with me. Work with me, or I'll work with you. I don't mind. If you've got things that you're doing that I can help with, then I will provide you with help. And there are certain individuals who are doing interesting projects who are keeping things quiet, who I am working with and trying to supply both suggestions for things to try out and to get working, and my modules so they can make things work themselves, and also providing hopefully feedback that it is really good, the things that they're doing, and I'm not sure that always comes across when I'm talking to people, but I do get amazed by some of the things that are done. Piers' stuff is wonderful. This other project that I've been feeding things back to is impressive, and it's been lovely seeing them using my components and managing to build something that is working. So it's not just me using it. There's been people like David Ramsden, who's been feeding some stuff into the actual code. Whilst we've been doing live coding, he's been feeding stuff into it. And he's been using the build environment and produced some work from that, which has been working for them quite well, which is awesome. So those are little things. They may not have like big fireworks things, because a lot of the people that are doing this work are, I wouldn't say quiet, but they're definitely they do their bits, they get on, they don't say so much outside of the private communications, and that's fine because not everybody wants to do that and become, in the nicest way, a target. There's quite a lot of awkward things that people say on the rule forums, particularly, and they can be quite harsh at times, and I can be a little bit harsh. I ask questions to try and make sure that I've understood things and that people have got answers, and some people have taken my asking questions as being a I don't believe in you, or no, I just want to know what's going on. I want to understand. I want to move forward. So that's the thing. So if people don't want to put their head above the parapet, that is fine. If they want to feed that through so that it's just fed into the 64-bit status work to say these things are happening, but not be attributed, I can put them down as individual A, individual B, or group X. We give them a code name if they want. That's useful, and we know that Simon and Paolo have used parts of what I've done, and I've pinched bits from their things where they've been useful, because it's open source, and that's what we do with open collaboration and the like. And the other part of that is that collaboration doesn't mean coding all the time. It can mean talking about the problem, it can mean testing, it can mean doing the interviewing, I suppose, is the thing. I mean, the sorts of things that we're getting here for questions is part of that collaboration. It's the people feeding things in that are introducing more communications. They're exposing things to more people. So as I say, I will try and get a transcript out of this as well, and I'll fix the closed captions as well. I'm annoyed that I think it probably got turned off automatically when I changed the interactivity. So when I was doing things, I did push the interactivity up to the highest level, and when you do that, you lose certain features, which I assume includes the closed captioning, because it's trying to keep the video in sync with the chat. It's trying to process it as fast as possible. So that's why. Yeah. So yeah, I hope that we get more open collaboration. And if anybody's been following me for a while, like past few years, you'll have seen that on most of my presentations and the like, I've always said, if you want to work with things, please do. Come and get involved. Talk to me. Don't talk to me, but just try and use things or whatever. But feedback is useful. But it's all there. Not all there, but there's a lot of things out in public that are available to people. If they want to use them, that's fine. It's their choice, but I won't push people to do so. I won't push people to use things, but it's always useful that they know that the stuff is there, hence the trying to communicate better. Right, so that's answered hopefully answered the open collaboration question. I shall take a breath for a moment, try and be calm, and yeah, we'll move on to some of the more technical ones. So starting with the lesser technical but about implementation one from Andrew, which is how much of Pyro's Python is host specific and how much is generic, i.e. prime for AI auto conversion. So the answer to that is some. Yeah, so I can give you some concrete examples. So let's go up from here. So I switch to coding section, and if we have a look in discuss, was PrettyPrint? I don't know. Oh yeah, most of the AI experiments are in this AI experiments directory. Let's bump the font size up a little. I think that's a bit small. Is that? Hopefully that's better for reading. Still looks a bit small. Let me just bump it a little bit more. Yeah, I think that's a bit better. Yeah, I think that's better. So lots of components here that are being done. Where's PrettyPrint? It's not there. Locate C/PrettyPrint. Oh, it's there. Okay, fine. Oh, but yeah, OS-wise, that's right. Let's bounce into there. CD there. Right. And let's have a look at the code in here. Anytime you want to, that would be good. I mean, don't feel you're having to rush or anything. I'm only broadcasting live, you know. Fine, we'll let that get on with it. Oh, there we go. It's decided to pop up a window over here and spin its little cursor. Right, we might be just waiting a moment for that. I'll keep talking whilst we're doing that. So what I'll do is I will pop over to another terminal and I'll go into Pyromaniac. So I'm going to look at the PrettyPrint because I know the PrettyPrint code was module still. Pyromaniac, RISC OS. So if we have a look in here, this is all the sources for. Come on, can we go a bit higher, please, so we actually can see the bottom? Yeah. That's odd. Wonder why it's got some files like that. Let's just delete those because we don't want them. Yeah. LS. Wonder why it's formatting to 30 columns, not to the entire screen. Don't know. Maybe we'll worry about that later. Oh, this window's a different size. Bottom of the screen. Right, are those fonts different sizes? I think they're different sizes. Just pull that to there. Ah, there we go. Right, we've got the same font size now. That's probably why. It's probably because it's. Oh, I don't know. I'm not going to worry. Anyway, less PrettyPrint. So this is the PrettyPrint module as implemented in RISC OS Pyromaniac. As you can see here, there is a dictionary entry that describes lots of things. Entry 22 is missing. Why is entry 22 missing? That's very weird. I may need to look into that. I've not noticed that before. And we've got some dictionary lookup code that goes and tries to do things, handles special tokens. So this is basically a abstracted version of it. If it can call them, it calls them. And this bit here, oops, wrong way. This bit here does the expansion. It goes and knows how to read a byte out of things, out of memory. If it hits an escape character, it goes and gets the byte and does another dictionary lookup, which itself might call into more dictionary lookups. And then the PrettyPrint function itself reads words, a word worth of text, and then goes and returns where it is in the range, so where it starts, where that is in memory, and what byte we ended on, so you can know whether you need to concatenate or what you need to do at the end of it. That's the code for the 27 code. Escape. No, it's 31. That's hard space. Hard space becomes an actual space and doesn't wrap. Got notes here about possible bugs in it, and then we've got the screen sizing to get the window width and handle all that and do it in words. So that's the algorithm that's used. I have no idea whether the implementation inside the kernel or OS-wise is actually like that, because I didn't implement it with any reference to the ARM assembler. So you've seen a bit of how that code is structured. My editor is still spinning, so what we'll do is we'll actually have to look at it in less instead. I'm sorry about that. We're just going to have to look at it in here. So if we have a look at PrettyPrint here, we've got Oh, this was AI generated, and I never bothered. It never bothered to even change my name in there. I'll fix that later. This is the token list, which you'll notice is very, very similar to the original one. And then the functions for get window width, getting the sizes, writing text. Here's our dictionary lookup, which goes and looks things up in the table we had there, which is trying to find things, and then we'll go and read out the different tokens. Special things there. Still not sure what happened to 22. Very similar table here, a little bit more expanded because we don't have a proper dictionary. Hello Arctic. Yeah, life's going well so far. I'm just explaining how some of this stuff was converted. We've got some break characters here, which is the characters that we could have as characters that split us up. I'm not sure that actually is. Yeah, it's not even used, so we could probably delete that. It was present in the Python code, so it's translated over. There we go. That's looking for the ends of words and then returning the results. And then we've got the implementation here. Again, not sure why it's done that. This needs a little bit of review and tidying up. Pending new lines, processing the words, which looks very similar to the code that was in there. If we just look back in here, deal with the word terminated characters, it's this bit here that's processing the words. So you can see the right ends, the new lines, where we broke the lines, and the new lines there. Basically, it's just converted it straight over to the same thing. Handling the terminator, escape characters and doing the dictionary substitutions, and then special handling, which is being done there. So it's all very, very similar here. That's the point of that. It was like, this is how I've implemented it, and now it's been translated over. And if we have a look at the other files in here, in C directory, we've got things like, not sure I'll confirm, redargs, I think, was converted over in the same way. C/redargs, was it converted over in the same way? I have a feeling it was. Read args. So this is the Python code. So the Python code has got a class here that manages handling a keyword and sets up a bunch of parameters of whether it's got different things in it. So whether redargs is a thing that has /k, meaning you must always use this, /k meaning you must provide the keyword, /s meaning this is just a switch, it doesn't take a parameter. It's basically a get opt but for RISC OS. And there's also equals values in there, which I think is actually an extension that I added, actually, come to think of it. I don't think that's in there by default. But then this is how they're passed in here. We split it up by commas, and then we process it and work out what keyword arguments we've got. And if you have a look in here, this structure is part of that class that we saw. It's got the exact same parameters in it. We've got some things because it's control terminated, not zero terminated. Error handling, passing the definitions. Here's our comma management here and looking for the keywords, setting the particular flags that are needed. So it's extracted that out of the class and put it into the structure here. And then that's returning that. And then we've got passing the input arguments as well with the quoted strings and the like. So it has converted over quite well. That's the quoted strings handling. It's taken all that out and put it into one function. So it can be handled in the same way, largely because we don't have classes in C. So that's a good example of some of the parts that can be handled as a what's it called, an easy translation from Pyromaniac. Not everything is that way. Not everything works in quite as easy a translation. But if we go back to where we were, so we were in the AI experiments, you can see there's a few of them. So I converted them individually. So redargs, and PrettyPrint were converted individually and then merged together. I did an AI conversion of the joystick. Joystick was one of the earliest things I did, actually. NetStatus did not use RISC OS Pyromaniac source at all. NetStatus was implemented entirely by pointing it at, this is the PRM documentation of NetStatus. This is a module that has been skeleton, so I did RISC OS project skeleton to create a skeleton NetStatus module, and I told one of the AIs, I'm not sure which one, probably Gemini, it's log. Quen, I asked Quen to do this one, and Quen basically went through and implemented the different handlers, and I just poked it and said, oh, these things should go together, this is how it should be handled. And it was entirely implemented just from the documentation. And that made a big difference because it meant that I could then convert the C code into Python code and put it into RISC OS Pyromaniac from the C. Which is the opposite of what you were asking, but it meant that I now have a NetStatus that is both in C and in Python, and I can interchange them. They are nearly identical implementations, which is kind of cool. We're sharing more of that content, and that makes a big difference. That does make a big difference. The specific question was how much of it is host specific and how much can be generic. Host in this sense is Pyromaniac host. There's very little that's like macOS specific. I mean, if we have a look in Pyro, we go over here and we go into PyMods. PyMods is probably the bigger area that's to convert. But if we go into the driver section, you'll see in here there's different real-time clock implementations. So the real-time clock on the RISC PC is 8583. I think it's the 8583. I'm not sure. Like the RISC PC. Thank you. I thought it was. So this is just an ISE implementation in there. How you've replaced the font stuff. Right, okay. So that's a good example. I'll come to that in a second. So in this case, this is the 8583 implementation, and largely it does vector claiming. Fair enough. But then the actual handling of how it deals with getting the years, it reads it from the NVRAM, and how it handles actually doing the RTC operations is all going through the I2C interface. So this module can be just dropped over to be a module that would just work and provide you the RTC interface for that chip. And the same goes for, pick another one, the 2127. The 2127 chip, which is a RTC with a larger memory, but it has a different API. But the API is implemented here. It doesn't have centiseconds, so we lose that. But otherwise, all it's doing is it's just querying the I2C interface. And therefore, this module would also just convert straight over. So if you had a PFC 2127 on your I2C bus, it would just work. So there's some bits there that work quite well. The specific answer, the question clarification that Andrew made was, by host specific, I meant things like how you've replaced the font stuff with Cairo's font rendering. So, ouch, that hurt. Let's jump back to where we were in the AI experiments here. So we have a look in here. RISC OS font qualifiers. So I'll jump over here actually. Let's do this. Let's jump to the so if we go to RISC OS font qualifiers, GitHub font qualifiers. Yeah, so here we are. This is the repository here that does font qualifier parsing. So what I did was I implemented font qualifiers. Let's clarify what those are. So those are, I don't have an example here. That's good. Let me look at the tests because it will show us some examples in here. Come on, show me the tests. So these are the things like /f Homerton medium /e Latin 1 for the font is called this, the encoding is Latin 1, and so on. You can also have matrices specified. That wouldn't mean anything. That would be an error, actually. But yeah, and there's things like having the qualifiers and applying fields to it. So it basically takes away the font, the Homerton, and replaces it with Selwyn, and we can check that the code is being processed properly. So this, sorry about that, I knocked the desk with my ring. This code is essentially the code that was in RISC OS Pyromaniac originally. This code here is literally just lifted from RISC OS Pyromaniac. And it's been made entirely available to people to see that this implementation works. And then what we do is we come over back to here to this code, and we go, we're already in that directory, and we can see in here that there's a qualifiers directory. Qualifiers. There we go. Which has got an implementation of that code. And this was implemented as .c files, so it's actually been implemented to run natively, run on my system, my macOS system, and then was later ported to run in RISC OS. So we have a look in there and see. You can see C/font qualifiers here. This is the code that has been translated. It was translated automatically, not by me myself, but by me managing one of the AI agents. And it's got all of the code that handles managing these font qualifiers and returning the errors back to it. All nicely returned, all nicely managed. And it's also created the test code as well. So there's now test code that is the same as the test code we had in Python, but implemented in C. So we can see that that works. And in theory, we could apply that to standard font manager and see that it would work there. It's not been done, but we could do that. So that's just the font qualifier code. That's quite niche, but it was an area that was quite, it lent itself a lot more to being written in Python than it did to being written in C. So writing it in Python and then converting it to C automatically was quite nice. The other bit that we've got that's interesting, if we go back a little bit on here, we should be able to see that's the font qualifier parser, but there's also the control code parser. Don't care about that. Now control codes, no, we don't have any examples in here. Let's see if we can find them in here. So yeah, you've got regular strings like that. You've got strings like 1A01. So that becomes a select font, handle 1, print this text. Select font, handle 2, print this text. And what we're doing here is we're decomposing that string into a sequence of operations that we can then see a font operation, a string operation, a font operation, a string operation. And then you can step through those operations to do the rendering or the string sizing or whatever. And because that code is written in Python, in here, all of that handling, it basically uses different classes and the like, can be converted into C code that will then be used to operate on the fonts. I haven't done that one yet, but it should be relatively easy. It's basically a dispatch table for each of the object types, which I don't think I've done that one. Let me just check. No, I haven't done that one yet. But that was all set up that way for that purpose. Because if we go back to the font manager here, core font manager, if we have a look at the font manager, there's that control file that we saw. Just have a quick look at it, control.py. You should see that it looks, yeah, that is the control file we were looking at a moment ago. So you can see that that is doing the right thing. But the actual module itself, each of the SWI calls, that's not right. That's what it should be. We can see the SWI calls here. So if we have a look at font paint, font paint, we'll see that the implementation of this, here we go, it does some manipulation of the flags, selecting fonts, handling lengths, manipulation of OS units, and the like, managing rub out boxes and spacing boxes, and justification, and all of the actual implementation. So even this, it just calls down to itself. It calls into font scan string to run through itself to work out the justification sizes. Where's the actual implementation of the calling? Here we go. Plotting the rectangle if there's a rub out box is just that. So you can see that these calls will easily translate. And then when it comes to actually rendering the text, we call video cursor disable, and then we call a paint call, which will actually do the rendering. And the paint call is actually implemented somewhere else. But the important part of this is all of the stuff that came up to this point is setting up the parameters that need to be done for the actual graphics operations. So those graphics operations can be implemented entirely separately. That's where the Cairo rendering lives. Is inside this particular function, but it's all been set up so that all it has to do is just do this string in this font with this spacing and these operations, change color here, do this here. It just knows what it needs to do, so they will be able to be translated over to other physical right to the screen operations. But the hard part of Font Manager is not putting it on the screen, it's the working out what the heck the interface is. And you could put a lot of things behind it. So for example, the rendering system that was used for, let's say, oregano is actually, I believe, in a module. You could plumb that in at the back end if you wanted. I don't think we're ever going to get hold of the oregano source, but that's a possibility. Same goes for the rendering system that is in Iris. Iris has a, I believe, and Andrew will almost certainly correct me if I'm wrong, has the FreeType library behind it. That implementation is just a bitmap manager. That's essentially all it does. It manages vectors and bitmaps. That could just as easily be ported in to be the back end of a font manager system. If you've got the front end part that does interface translation, the back end part can be whatever you like. And so this is quite ripe for being converted in that way. There's also this bit here. So if you just look down at the caret here, caret rendering, caret as in the little I bars that are used for things like this one. When you get that there, well, actually, when you click on the text here, you don't get that, do you? But that I bar anyway. This is all set up the flags, disable the cursor, and then call a function that actually does the drawing. That's all it does. And if you look in here, caret.py, you'll see that this caret operation is literally just calling down to the graphics system to plot some lines and circles. And that's it. That's all it's doing. Draw line, draw line, draw line, draw line, and then maybe some circles as well if you've got the looped versions. And And that means that it just works. If we have a look, if we go back to the AI experiments and look in the caret directory, font caret here, cd caret, lsc, yep, so less c/caret. And in here, again, I skipped through a lot of that, but you'll see line calls, circle calls, draw caret, handling different colors and the like. And then there's exactly the same pattern because it's exactly the same code. It was just converted over so that it does work exactly the same. But of course I could write it in Python and see that it was working far more easily. Wow, that answer took a long time, but I hope you can see that because of how I've tried to structure things and written things in a modular way, not trying not to be entangled with RISC OS interfaces, but doing the conceptual things, it makes it a lot easier to try and translate it over. So I hope that answers your question, Andrew. I hope it makes it a little bit more obvious some of the bits that can transfer over. Some of the bits are going to be very hard. Some of the bits are going to be mind-numbingly difficult. Other bits, on the other hand, will be simpler. Yeah, I'm hoping anyway. Sorry, that was a very quick run through. Again, if people want more detail or they want to talk to me privately about things, do feel free to grab me. I'm happy to talk about things. It's nice to talk about things here in public because I can then give a little bit of demo in the code side as well, and people can see the sorts of things that we are trying to do and the actual coding that it has with it. Right, so that hopefully answers Andrew's question. He said thank you. So Nitrex Alan asked us, vectors. Tell us about vectors and the difficulties getting it 64-bit and sensible. Okay. So let's start with what vectors are, because I don't know that our audience has all the knowledge of these things. So vectors, a lot of interfaces, not all of them, but a lot of interfaces in RISC OS go through vectors. And it was one way that the system became quite modular, was that you could have, for example, your draw operations all going through vectors, so they could be translated to be managed by the draw module, or you could have another module that sat in front of it and did things differently. So the standard draw module just did Bresenham curves, Bresenham lines and curves, but it didn't do the anti-aliasing on them. And then Computer Concepts came along and they went and did their G-draw? Can't remember what it's called actually. C-draw. I think it was G-draw, which had the anti-aliasing applied to it as well. So you got smooth curves out of it, but all of the interface stayed the same. And that was quite cool. It's also how the printer drivers work. The printer confirmation it was G-draw. Good, thank you. The printer drivers, instead of letting you just draw to the screen with draw or osplot or any video operations or sprite operations, it claims those vectors, and instead of it going to the screen, it goes to the printer driver, and the printer driver processes it. And that means that you get the same operations but happening through a different path, which is actually kind of cute because it just means you do the same sort of rendering but it's just going to the printer instead, which is cool. Internally, vectors are, you say, I want to claim this and I want you to call me here. Fair enough. And I want you to pass me a parameter that gives me details about my context as well. So the private word. And then when a call is made to the thing that uses the vector, it then goes and calls all the vector handlers to say, do you want it? Do you want it? Do you want it? Do you want it? All the way down the list. Fair enough. But technically in ARM 32-bit, in order to say I want to handle this, you claimed the vector by pulling a value off the stack, which is clever in the way that it was implemented, but a pain in the behind if you want to try and deal with it in other systems. Why is it difficult? Because there are stack limitations. There's the 64-bit version, and it has a stack limitation of 2 registers, two words, sorry, on the stack. And the words are 64-bit, so it's actually 16 bytes you have to remove at a time. And that makes it a little bit more awkward. Not impossible, but awkward. And then there's the fact that if you want to post-trap the vector, post-trapping the vector means I've been called, but I want the original handler to do its stuff and get passed on to all of its handlers. And then I want you to come back to me and I will do some more work. And maybe I'll call those handlers again. And then I'll maybe claim it and return back to the host. And oh my gosh, is that complicated? Because that doesn't fit nicely with the way that you would actually do, well, most things, to be honest. If you want to do that, there's a lot of work involved. So I'm going to have to handle those cases, and I haven't done that yet. In the 64-bit design, I haven't actually handled the how do you claim vectors problem yet. And I am now at the point where I really need to do that soon, because you can't really use it. And people who have been trying to do this, like one of the people who's been using my modules, have found that it works, but it's not really working properly. We need to have some handling for that. How do we claim things? How do we post-trap things? At the very least, how do we claim things? It needs to be handled. So that's a difficulty that I'm still trying to get working. And the other part of this is another part of it, because there's not just there's many different facets to it. All modules and all of these vector handlers have got to go through, would usually go through CMHG and use CMunge to be able to handle it. So I've had to implement the CMHG veneers in ARC64, as well as the ones that were in 32-bit, as well as the ones that are in 26-bit. And so we've got now a code path in CMunge that has 26-bit, 32-bit, 64-bit, and not all of those are implemented. The 32-bit one has almost everything implemented. 26-bit is implemented everywhere, I think, but the 64-bit has a number of interfaces that are just not implemented yet because we haven't got around to defining them, and that's something that we need to handle. So yeah, there's some different areas that have knock-ons. So, and when I come around to implementing that, there's going to be different places that need to be fixed. So there's going to be the Pyromaniac vector dispatch. There's going to be the every module is going to need to be rebuilt with the new CMunge that has the new vector dispatch, and then anybody that's implemented to use that will need to change over. So that's why I wanted to get these things sorted early, but I hadn't expected to need to do it this early. So that's why the vectors are a bit of a pain, and why I keep cursing them every so often. I hope that answers your question, Nitrex. Right, so that's answered all of the questions that are on the chat there. So what I'm going to do is I am going to, I think, take a short break, and that'll give people a chance to offer some more questions if they want to, or I will come back to some of the questions that we've got that I got emailed to me. So I've got 1, 2, 3, 4, possibly 5 more questions that have been emailed, some of which will run together as we answer them. So I'm hoping that will be interesting as well. I hope you've enjoyed the answers that we've had so far, and hopefully some of the demonstrations that we've had of the code and the like. What I'm going to do is I'm going to put us onto the break titles, and I will go and take a short break and grab myself some more. I've still got half a cup of tea here. I think I've been talking a lot, but I'll need to pop to the loo and things anyway. So yeah, I will go and take a break. Please fire off new questions if you have them, or if any of the things that I've already asked need a little bit more embellishing. Please do ask. I'm happy to answer. Yeah. See you all in a little bit. Okay, bye. Oh, and I need to mute things. Hello, I'm back. Oh. Right, here we are. Oh, such a bright light outside that window. It's very bright out there, and the wind is blowing like crazy. It's very windy, very windy here. See you later, Rob. Hope you get to catch it later on. Right, so we had no other questions, so I shall work through the remainder of the ones that I had emailed. Start with the first one, which is, what do I see as the biggest advantages users and developers will gain from a 64-bit transition? Well, the biggest advantage is continuity. So, in theory, it'll mean that you should be able to continue using your applications on a RISC OS system, which have been built for modern RISC OS, and which exist on chips that now are still here, because at some point, the 32-bit supporting chips will stop being a thing that's available. I mean, that'll take a long time, but they'll be more and more scarce. I mean, you can still buy almost all chips that have ever been in some form, because there's generally support for them, and they're often quite useful in different environments. But they'll become less and less common, and there won't be any advantages for them. And since nobody is making physical hardware, the physical hardware, the Pis, the various embedded systems, Pinebook, for example, will end up being only 64-bit. They won't have the 64-bit, 32-bit cores in them at all. And we've already seen that the systems that have got only 32-bit user mode, and that is just the way that it goes. So there's going to be a lot of pressure to try and handle those systems, and we already know that the Pi 5 has no 32-bit SVZ mode. It only has user mode. I think it has sys mode as well, because that's a user mode. But without that, you just can't run RISC OS. You have to run it as a 64-bit system or a user mode system that has some other protections on it, and that starts to get hairy. Doable, but hairy. So the advantage is continuity. If you don't want physical hardware, then that's not a big deal, because you can then basically use RPCMU or another emulator to run the system. There's no reason why, for example, you can't have so RPCMU is the primary emulation system, but any of the other platforms could run RISC OS, basically. And you could have them running not as a RISC PC emulator, but a different system. The main reason is that RPCMU is the primary one, is that it's just more ubiquitous. And RPCMU, the authors don't want to start introducing the other processor extensions and hardware needs for different types of systems. They're targeted just at being a RISC PC emulator, which is fair enough. That's all they want to be. That's fine, but it means that there's no additional advances on that. On the other hand, that does mean that all your existing software that could run on RPCMU continues to run on RPCMU. So you can just run those as you would previously. And then you keep your continuity of software. You can run that on your Windows machine, your Mac OS machine, your Linux machine, your machine that's running whatever other bizarre system presumably it works on BSDs. It's been absolutely years since I've seen a physical BSD machine. Yeah, just don't use them. But that's part of it. The other part of it is that the side effect of the 64-bit transition is having maintainable versions of the modules that we currently use. So getting rid of this assembler code that's been around for goodness knows how long, something that absolutely should have been done 20 years ago. Bear in mind that certain people were working on that, and that was not of interest to people, so not bitter at all. But the fact that it has not been a concern for other people is itself a concern, because it means that your developer community has shrunk because it's a pain in the behind to work with assembly. It's a pain in the behind to go and fight your way through some of the very special code and build system that is RISC OS. And that means that the existing developers have moved on because they've got more interesting things to do where they don't have to fight the system itself. And it has been very difficult to gain users from outside the community because, well, it's just difficult. That there's one of the presentations that I did, not presentations, the live codings I did, was it a couple of weeks back, when we were doing icon rendering, and somebody popped in and said, I can't believe this is so hard to just get icons rendered. You just use this XYZ library, and it's tiny, it's only 4 megs. And I was like, yeah, 4 megs is kind of our baseline aim for the entire operating system. We're not going to hit that. We realize that it's not going to happen, and we don't care because it's not important. But that's what we're aiming for. That's the sort of look that we are aiming to have. And so just a system that does graphics that is 4 megabytes, that's not a small system, not in RISC OS terms. Now that attitude is going to have to change generally. But the general feel for things outside the community is, oh yeah, that's fine, we'll just do X, Y, and Z. Well, there's a component that somebody wrote recently that was, I can't remember what it was. It was something that somebody wrote that ended up using like 8-9 megs or something, and the original implementation, was it Filer? Was it somebody rewrote a Filer and it ended up being 8 or 9 megs rather than the like 40k or something? I don't know how big Filer is. I don't think it's 40k. Projects, modules, RISC OS source, desktop, Filer. It's 50k, I apologise. The 50k that Filer is. And that's because like it's a different way of thinking about things if you're writing stuff in higher level languages. And you tend to do things more structured and all the rest of it. That's a price you have to pay for writing it in a better way. And in general, we need to get out of a mindset of, oh, it needs to be small. No, it needs to be maintainable, because then we can maintain it and we can have more than just the people who want to work with ARM assembly doing stuff. The people should be able to just tweak things. So that is another big part of it, is that not only does the 64-bit side become more manageable, the 32-bit side also gets a advantage in being able to do that, assuming that people use it, which maybe they won't, but that's the intent. Anyway, that's hopefully has given a reasonable answer to the what do you see as biggest advantages that people will gain from the transition. I mean, the actual users at the end of it, the continuity is the goal. I mean, If people don't consider that it's a system unless they can run 32-bit, then there also needs to be a little bit of a mindset change of, right, I want to use this thing from a legacy system and it doesn't work on XYZ. I'll just use an emulator rather than trying to use hardware. Just get out of that particular mindset. If you want to use the actual system and support it, then fine. But if you want to be continuing with everything working the same way as it did previously, and I admit that I'm trying to keep everything working the same way to help that behavior, but some things aren't going to work. We're not going to get a transition of some of the 26-bit, 32-bit things into the new world. Then that's fine. Stop requiring that. Stop demanding it, because you are the people who are holding things back. You are the people who are going to cause that are contributing to the lack of development in the system. And if you want to have things that keep working, you've got a solution in emulation. So do that, or your physical hardware from the past. I'm sorry if that's a little harsh, but tough. Right, I hope that answers that question. There's a question from Nitrex of, what part of RISC OS conversion do you least look forward to are you least looking forward to and most looking forward to? So the ones that I most look forward to, I've tried to get done as soon as I can. Although I am looking forward to having a play with the font manager, unless somebody else wants to take it on before I get to it. I mean, I've done some bits of it. I will defer to anybody else if they want to take on any of these parts of the projects, because why not? Why put more load on myself for these things? But the bits I have enjoyed doing. Oh, let's have a quick look. Let's have a quick look at the status, because that's probably a good sign of what's been fun. I really enjoyed doing debugger. I really did enjoy doing debugger, because A, because it was my first live coding part, and B, because it gave us a nice way of, these are open source components, we are pulling them in, and we have now got something that we can use it for. And yes, it's heavily bloated, but that's not a big deal. It's something you can use. What else did I enjoy? This lot, not too much. I'm quite enjoying doing video software. That's moving along quite nicely. We've got some parts of that working. Evaluate expression. Now, evaluate expression, I wrote, this is one that I wrote in the Python code, and it worked, but it didn't support unary minors. And I was having real difficulty making it support unary minors. Unary plus also wasn't working, but unary minors is the one that matters because you use that more often. And I got Quen to convert it over to being in C. And Quen took it and ran with it and had some real difficulties, because at the time I didn't have a lot of the basis of how agents should work. It was one of the earliest things that I got it to do, and it didn't have this is how you test things, this is how RISC OS works, this is how file names work, this is how you build things, this is how you run tests, this is how we exercise the module in particular ways. And it had some great difficulties, and from that I taught it what to do, told it how to do things, and then from that wrote up myself, these are the ways that you start porting things from Python to C. And then I ran it through it again using the same sources and said, okay, this is what you got, go and do it again. And now I had some tests in, and so it started adding tests in BASIC. And it got the hang of writing things in BASIC, and so we got the skill of writing BBC Basic out of this as well. And along the way, it spotted that unary minus wasn't supported and implemented it. And it was like, oh, we've got that now. Oh, that's nice. And then Quen went to being unavailable because it was free early on. And so I switched over to using Gemini. And I fed it into Gemini what Quen had done. And Gemini had a look at it and went, there's some bits here that could be done better. There's these things, this. And so it went and rewrote some sections of it and made it a little bit more, not optimal, but just a bit more nice to work with. And I asked it questions about some bits of it and it rewrote them in a nice way. And so now we've actually got quite a good implementation there. Oh, Gemini also expanded all the tests much, much more. And whilst Gemini was doing that, literally whilst it was writing those, doing the reoptimization and everything, I was in the background or in the foreground, because it was me. I started porting over the Pyromaniac code that tested it. So all the execution that was in Python, in ARM assembly, that just exercised the evaluating of expressions and checked that everything looked right. So we had its tests that were testing that it looked right from a sanity perspective, and then my tests that were actually, this is what RISC OS itself should be doing. And that really came together well because it could then cross-check between them. Having these tests is vital so that the agent actually knows what to do and doesn't just make it up, because it can make good decisions. It is a junior engineer. It can go, oh, this is the kind of thing you want. You've given me bad instructions. And I don't feel like talking to you to ask questions, because agents are hard to. They will ask questions, but they will just assume that they know what you're wanting. Sometimes they get it right, sometimes they don't. But with their actual test results and the test system for the thing you want, it can target it at that, and it gets the right way of doing things. And that makes a big difference. So yeah, evaluate expression was a real one that I wasn't looking forward to, but when we got there, it was a lot more fun. If we just have a look back at phase 2, I don't think there was much in here that was exciting. No, net status was good, as I mentioned. Value expression, conversions. Desktop's kind of working now. It's not bad. Text rendering and then sprite rendering were I knew were going to be quite easy because they were a port over from the Python. So that really did hurt a bit, but I did those by hand. But what am I not looking forward to? If you have a look in the desktop section here, this has got a number in here. Let me go through these in here. Exception handling, memory management I'm working on. VDU system I'm both looking forward to and not looking forward to. I've started some work on it, but it's fun. The sprite system, I have a good chunk of that implemented already, and that's been a really interesting process and really fun to do that. I'm not looking forward to the filing systems, particularly FileCore. Do not want to do FileCore. Don't mind doing file switch, but FileCore is not a one that I'm looking forward to. Within the WIMP, window management. So window management is you've exposed this window and this one, and now it's moved over here. Work out what the optimal way is of drawing that, and like that process of compositing is not something I'm looking forward to. I'm sure I can probably do it, but it's not something I've really got my head round. It would be nice if somebody who knew the WIMP or knew that form of geometry management could have a look at that, because really all you need to do is implement the algorithm for this is the area that we've got on the screen. This is the area this is the operation moved from here to here. What are the operations we need? We need a block copy, we need a re-render of this area, and we need these things doing. that's what we need to be able to do. And it probably isn't hard when you break it down, but my head is just finding it difficult. Yeah, file switch. I'm not looking forward to. Do we have file switch and the like in here? File core was in here. Yeah. There's some other bits there that are going to be quite fun. Applications level. Toolbox I'm kind of not looking forward to, but it should be quite easy. And then printer stuff. I'm hoping that people like Piers will be able to handle a bunch of the printing stuff, and I won't have to worry about it at all. But that's also true of many of these components. I just hope that somebody will pick them up and go, oh, that's something I can do. I'll just go and look at that and see what it is. They'll go, oh, right, let me have a look at, I don't know, one of these modules. Actually, most of these are in C, so it's not such a big deal, but IC adjust. There you go, that one. There isn't even very good definition of what it should do there. But taking that into and converting it to C probably isn't hard, but I'm not looking forward to it. Managing any of the hardware drivers like the CDFS soft drivers, the parallel device driver, serial device driver, not looking forward to them. Really not looking forward to them. So, interesting question there. Let me just see what we got to. So, of the questions that I had emailed, yeah, let's just take one email and then I'll come back to you, Nitrex. Actually, no, I'll answer your question first because I know that you tend to go earlier. So you asked, do you think converting ARM2 focus code to a high-level language that gets compilers to new processors will unlock performance gains? I realise that's not the goal, but I'm curious. So that is an very interesting question, which I think the answer is they only get benefits if you are not converting them based on the ARM2 code. If you're converting them by concept, then you'll get more performance. So let's take the implementation of the draw module. So the draw module is implemented by doing operations in ARM that are multiplications and divisions and basically doing the Bezier curve management and then searching for line crosses and things like that. The line crosses probably not much different. But the case of the Bezier code management is flattening those curves has quite a few operations. Also matrix calculations in there as well. There's multiplications and the like in there. I believe the ARM code actually does use mul now, but modern processors also have div as an instruction, so we can gain from using div. Woo! We can also use the knowledge that was there originally to be able to do things better, and the compiler will do better code in some cases. Handcrafted assembler will always do better if the algorithm is right. But if you've got the high-level code that we can do, we can actually like profile that and decide, oh, well, this bit is actually the difficult part that needs to be optimized, and we can make that handcrafted. We can also change the algorithm so that it becomes better for a particular processor and have different processor implementations if we wanted. So, could we gain performance? Yes, definitely. Will it matter? I don't know, because the CPUs will be so much faster as well. Definitely by having it coded in a high-level language, if the algorithm stays the same, it will probably be slower. But does that matter? Maybe, maybe not. Until you've done it, you don't know. So there is the possibility, but I wouldn't bank on it, basically. On the other hand, there are interesting things that come about. So we've already encountered the improvements that have been seen by replacing the floating point emulator with accelerated code, so using the VFP on 32-bit. Obviously, that's got limitations because on 32-bit, floating point is an optional feature. However, when ARM put together the ARC64 specification, they learnt from that mistake. They decided, right, there is a baseline of floating point operations that are required. So your baseline floating point operations and some SIMD operations are actually in ARC64. And that means that you can absolutely rely on having floating points there. So no emulation and no running through soft float operations. Yes, your floating point operations will be slower than integer operations, but you'll be able to use them and retain more accuracy at higher speed. You can use doubles, you can use even quads if you want to, but I think quads are actually an optional thing. The point there is that, for example, if I go and compile a program that uses floating point on a 32-bit system, it'll go through the floating point emulator, or it may be able to use the VFP. But for the 64-bit side, it will always be able to use the floating point system. And because it can always use the floating point system, it can always be faster. Or you can choose to use the integer side operations instead. And that means that we do gain from those operations because they can be faster. Concrete example. A little while back, week or so back, Bag of Spanners, you may have seen him, did a little example of fireworks in one of the I can't what it was. It wasn't Unity. It was one of the other systems anyway. But most of it was just in C or C++. Can't remember which. And so I ported that to C. External ports. The code guy says, "Hi sir, how do you get good at programming? I'm so dumb. Lots of time working at it. So I started when I was 9, 10. I'm now 49. So, and I've grown up with lots of different changes in computing. But that's the thing. And lots of isolation and avoidance and mental problems. You got to be a bit insane sometimes. But that's basically how I get good. Lots of practice. Explosion. So I think this is it. So we have a look in RISC OS here. Right. Open / screenshot.png. There we go. So here we are. This is one of the screenshots of it actually running. This is it running as, I think, Dave's program. Now, if we look in here, ooh, this doesn't look like it's been compiled. That's interesting. Compile that. Ooh, I thought I'd got it working. No worky. I thought I got it working. Surely. It was working at one point. This cost ammo. Build 64. I run this. I swear I've run this. I did. My wife is confirming that I did, because we've had screenshots. I wonder if Explosion.h wouldn't open. Develop is Dave's. Oh, hang on. Branch. Ah, this is, yeah, I tried porting it different ways. I think I went to codecs. There we go. That's stash. What? X row. AI experiments. Is it in there? No. I'm all confused. Get status. Check out my branch, which was whatever it was called, codex. What codex? The following working tree would be open. Okay, so let's do git add. Just add those files and then stash them away. Dum dum. Oh, excuse me. Check out codecs. Oh, stash. Right. This costs 64 ammo. I'm not in the right directory now. Good demo, this, isn't it? For Pete's sake. Oh, micro explosion. Oh, is this something? Yeah. This is the ones where it got confused and decided it was a library. Right, so Pyrodev 64-bit common command af64.explosion. Oh, and I want it in a window, don't I? If I don't do it in a window, it won't do anything. I'm 59 now. Did I say 64? Am I confused? I may have said the wrong year. I'm 59 anyway. Right, there we go. That's it trying to do its rendering. And as you can see, it is not ideal. It's a little bit slow. I'm 49. I have no idea what age I am. I'm 50 next year. Oh, for Pete's sake. My mind is already going. I think you already knew that. I think everybody knew my mind was going. Oh, just shoot me now. My wife is disagreeing with me, saying that we're not going to do that. So it's, as you can see, it's a little bit slow here. It's not ideal. If I just unstash. Yeah, that didn't work, did it? Sorry, OS. Status. Oh. Check out those files. So yes, that's an application that is that I ported from Dave, Bag of Spanners here. I think we can actually change the code as well. So if we change the code so it doesn't do quite so many particles. RISC OS number of particles 120, 40. There we go. Let's try and make it smaller. So the other thing you have to remember about this is not only is this running in 64-bit, it's also running under emulation. So if we ran this program on a real 64-bit machine, it would probably run a lot faster. It would almost certainly run a lot faster. Oh no, that still didn't work very well, did it? Still very slow. Ah well. I definitely got it working better than that though, I thought. Oh yes, I'm recording video and doing multiple streams at once. That's probably going to be hurting it, isn't it? Maybe that's affecting it. But yeah, anyway, you can see that there are things there. Anyway. So I hope that answers your question, Nitrex, that yes, there are possible gains, but they're gains from the hardware. Right, next question. Unless anybody's got any other questions. If you could implement 3 major improvements in 64-bit RISC OS that weren't practical in the 32-bit world, what would they be and why? Ah, dear. So, many of the things you could do are actually possible in 64-bit, in 32-bit. It's just they're not great. Widening the address space is one that absolutely only exists in 64-bit. That makes a big difference. That could be a big deal, but you can't do that until you've actually got something that works. Otherwise, all of the system is just too... You won't get anywhere if you just increase the address space to 64-bit. All programs will have to change, and all interfaces will have to change. If you have to change all interfaces, you've basically got to get it there quickly so that your developers don't run away, and you've got to give them lots of help in making their code move over. And that's what we're trying to do by just keeping it as 32-bit address space. That's something I'd like to do, but it's harder. One part of the moving to 64-bit that would change a large amount of things, but actually wouldn't hurt too much, is changing the process model, or part of the process model at least. So taking part of the process model away from the WIMP managing it and moving it into the kernel managing parts of it. So A and B control plus, basically what task control was going to be, is something that you could do, because there is no existing software that is using the system, and all of the code that will be written will be going through the C library at the moment, and therefore you just replace that part of the C library and everything works. That is something that I want to get to. That would be a really useful one. And I don't think there's much else in the 64-bit that would be like major, because we're wanting to keep as much as we go the same. You're tied into a number of different areas. There are small things like fixing up APIs to tie them down to particular implementations, or particular interfaces rather, is important. But yes, there are certain things that would be a big improvement, and they are the social and the attitude improvements. So not focusing on the, oh, it works on this hardware, or it is a issue with this particular type of system, but it works on a general RISC OS, so it may or may not work on 64-bit. There may be issues with that, but we have to be more generalized about these things. We have to handle things in different ways, and that means testing things in different ways. So not just testing, oh, this is the ROM for a Pi. This is the ROM. No, we should not be thinking in those terms. There should be the hardware layer that goes for a particular piece of hardware, and there should be the operating system that sits above that. And the hardware layer will work with a given operating system, but the hardware layer is fixed for a given piece of hardware. I mean, it can change, obviously, but it's not something that changes with the operating system. The hardware layer is like a set of interfaces between them. It's what you would call a hardware abstraction layer, but it's done through modules rather than through the nasty way that it's been done in the RISC OS 5 series, which is baking it into the ROM and making it a blob, which is anti-RISC OS. RISC OS is a modular system. Device drivers are modules. Doing it that way is not the right way of doing it. And moving to 64-bit and testing things in a modular way and making sure that you can run individual bits as you go and replacing segments, that lends itself perfectly to modular development and doing things the RISC OS way, not the set-top box way. So that would be a useful thing. And the other bit I mentioned as the social part was this is a collaborative project. This is something that is being developed not by an individual. It's not being developed by me. It's not being developed by Rule. It's not being developed by Simon. It's not being developed by another developer. It is a collaborative effort that everybody gets involved in. People do work together on these things. Now, current evidence is that that's not the case. There are not so many places where collaboration is happening. This calls back to the previous question about would I like to see more open collaboration? But that is an improvement that I would like to see in this, and it wasn't practical in 32-bit because everything was or is assembly. Not everything, a good chunk of things. So that's what I would like to see as a major change. Right, that's my answer to that question. There's another couple of questions that I've been emailed, which are also quite large as well. What assumptions or expectations do you think the community has had about 64-bit RISC OS that are actually misconceptions? I kind of touched on that in the other answer, which was that that's itchy now. It is just itchy. I'm bitten or something. That 64-bit is something that will come about and other people will do it. It's something that people should get involved in. I mean, that's true of the 32-bit as well, but unless people get involved, it's not going to happen. I mean, I'm going to get a reasonable way, but I'm not doing the hardware. I'm just not doing that. Somebody else is going to have to do that. So it's going to have to be done by people that are skilled in those areas. And it should be the case that people focus on the areas that they have skills in. And if somebody produces something that is okay, but it is not their area that they are skilled at, somebody who is skilled in it should be able to take it over, rip it apart and put it back together again in a way that is sensible. And that should be done rather than rewriting things. It should be done as part of a review of things of like, this isn't quite right, let's do it this way. But it shouldn't be a multiple strands of things. We've had multiple strands of USB stack in the dim past. We've had strands of the operating system. We've had strands of the internet stack. There's nothing wrong with having different strands of those, but in some cases that's because people just didn't want to work together, not because it was the right thing to do. Sometimes it's absolutely great to have two different implementations of things. We've got the original pinboard, for example, and we've got pinboard 2 that's been developed. We have got Filer, and we've got the other Filer, CL Filer, I think it is Cloverleaf's version. And yes, it's stupidly large, but it is another version. So, yay. That process is good in some cases, but where it wastes time is the people just not accepting that this has been done. Let's stick with it because there are other things that are more important, and Internet Stack is the core of that. My complaint on that. There are others, but that was a huge waste of energy on. I'm not going to take sides on this, but there was a huge duplication of energy. And I think people who know me know where I land in those things. Does that mean that I'm also duplicating work that other people are doing? Well, probably. But also I'm trying to take things from things that people have done. My C library is largely a lift from FreeBSD and NetBSD. And some other sources as well, but they're all open source things, so they're all clearly able to be used that way. RKey SDK is a SDK that targets smaller systems with GCC, and I've taken a couple of little bits of ideas from that, and I've put some things into that because cross-pollination is good. The question was, what assumptions and expectations do you think the community has about 64-bit RISC OS that are actually misconceptions? So I hope I've hit some of those points. One of the assumptions I think that people have is that there's going to be some hardware out of this. I'm not targeting hardware. Other people can do that, and other people are aiming to do that in some cases. It makes it a lot easier if you can do that. And that is a wonderful goal, but I'll leave that to those people that have those skills. Same goes for FileCore. It would be wonderful if, for example, somebody like David Rook was to take that on, or somebody else who knows FileCore well. There are a number of people who do know it well, to rewrite it in C, because I don't feel I can do any sort of good job on that. You'll notice that I've got effectively a file switch for RISC OS Pyromaniac, so I could probably do that. I may not be the best person, but I could do it. Parts of the window manager, I'm basically putting together the structure of that. I'd like somebody else to try and fit some other bits together on it, or to try and fit in other places that are useful, because why not? Why not get the whole thing to the point where we've got something that works for multiple systems? That would be awesome. Yeah, I hope that answers. It's maybe not as clear as it might be, but yeah. So Martin, as RISC OS Tech said, FileCore needs replacing. So the difficulty there is FileCore does need replacing, but you have to have a migration path from existing FileCore to another system, particularly if people are wanting to transfer files. So there are many file systems that exist and could be ported. They need porting. Again, just needs doing. But if people want to use their old disks, and they almost certainly will, even if it's just floppies, they will need some sort of implementation there. Maybe that's a read-only implementation. Maybe that's what we need. I don't know. But some decision on that is a good idea. That's not even an architectural decision. That's a strategic decision that needs to be made. And I haven't got a particular viewpoint on that. Well, I have. Yes, I have got a particular viewpoint on that. FileCore needs providing, but a secondary file system is where we need to move to. It would be lovely if we could move to Ext, one of the Ext variants that was available for under BSD or MIT license. That would be lovely. If we could move to something else that also has equal tooling and understanding, that would be great as well. But it also needs to retain the. I mean, this is basically the discussion that we had back when we were at RISC OS Limited. It's the same discussion of where can we go, how can we make that transition, And at the time, a lot of it was punted because it was just it was a lot of work for people. With AI, there are real advantages to being able to get some stuff ported over. So that does help, but it still needs the brains of understanding RISC OS behind it and trying to make it efficient, because RISC OS still needs to be efficient. So that also may be an answer to that. There is a final question I've got that was emailed. So unless anybody else has any other questions, this will be the last one of this week. It has been a reasonable session. This we've had what we got 2.5 hours right now, just Q&A. Nice, with 10-minute gap, obviously 15-minute gap. And this is the final question is a more wide one. It's good. Can you explain what is I'll try that again. Could you explain what the intended end state for 64-bit RISC OS is? Which technical hurdles are still open, and what needs to happen before an alpha build can become realistic? So there's a bundle of questions there that all go along the same general line. So my 64-bit end state is RISC OS Pyromaniac running 64-bit modules with full support throughout the system, so you can run and test 64-bit implementation of RISC OS on there, hopefully running all the graphics and potentially the WIMP out of it. I'm not too worried if we don't have a WIMP out of a desktop, because honestly, once you get to the point where you've got a desktop, you've got to have so much before that it sort of works. But that's where I'd like it to be. Which technical hurdles are still open? So implementing most of the modules. Technically, there's the exception interface, the error handling, the bits of the program model, process model need working out. I've mentioned vectors. Those are the main things. There's some strategic choices like how you distribute it, but my choice on distribution is distribute it as modules that are relocatable, because that's RISC OS. Stop thinking, again, this comes back to the previous assumptions and expectations. Stop thinking about ROMs. Think about a collection of components that go together as a release. That's not a ROM, because ROMs are read-only. Just stop it. We're not in that mindset anymore. We shouldn't be in that mindset anymore. There should be a release distribution that should be for the operating system and release distribution that's for hardware. And those two should be melded together to make a release that will run on a particular piece of hardware. That's what you want to have at the end of it. And what needs to happen before an alpha build becomes realistic? We're doing it. There are alpha builds of all of the components that I have produced. They are sitting in the sources directory, so I'm still on small view. But over here, if we go to here, we've got 64-bit builds of a variety of modules. And those same modules are also available in 32-bit. Here we are. So you can test those same modules in 32-bit and see that they work. And see that they are built from the same sources. If they work in 32-bit, then there's a good chance they'll work in 64-bit. And there are tests that go on every time we push that check whether things work. Please don't have any X's. Thank you. Right, so wiki updates, testing all the binaries here. This job tests 170, 162 passed. There were some that were skipped because they need other things. So if I look here, my map was skipped because it looks at files that don't exist. Remote printer support needs ShareFS. Fair enough. Sprite utils, there's no sprite system, so yeah. But all of these things are being exercised. All they're running here is just, do they load? But they could be expanded in the future to do more things. This is a big benefit to us to have all these things done. We should be expanding the tests on these as well, so that we do more stuff. I'm going to give a short example as that question pretty much answered, I hope. But to talk about testing. So, to talk about testing. Where have I heard that before? Almost every time I speak. Testing is something I care about a lot on RISC OS. One of the things that was on the pdriver thread that Piers started, Piers Womble, is RISC OS 64 going to be RISC OS 7? No, RISC OS 7 is Pyromaniac. Again, this is down to what we should be calling the distributions. RISC OS 7 should be an API that you're meeting, I guess. But it should, RISC OS 64 will be RISC OS 64, I suspect. Branding is again a marketing issue rather than a strategic or architectural issue, and so I leave that to other people. It's important for me to try and separate out what the issues are and whose responsibility they lie with. And the reason for that is the earlier question that Nitrex asked, which was, how do you stop yourself getting overwhelmed? That allows me to just focus on the things I can do. It also means that I stop overstepping my bounds. So I can say that I am calling RISC OS Classic, all the assembly version of RISC OS is RISC OS Classic. All of that is Classic. All of the stuff that's in Python is the Pyromaniac implementation. There are other implementations. There is Simon's and there is Paolo's, which all have their own names. Simon's is the, I can't remember what he's called it actually. I don't think he's actually come up with a name properly. He was asking for names, I think, a little while back. But there's also Paolo, his system's Merlin, which has a RISC OS personality layer. So there's different code names, or actual product names for those. And that's how we should be trying to think of them. RISC OS is the interfaces. That's the thing you are talking to. And each module will have a particular set of interfaces. And there may be a release version or a release code name that gives you a particular bundling of those things. But that's what you get when you've got divergent implementations, open source, open implementations. That's where you go with that. I'm not sure where I was going with that. That was the naming things. Oh yes, I was talking about testing. So testing is vital on everything, and you'll have seen that I've done a lot of testing. One of the comments that came up on the pdriver thread that Piers started was about him using AI to give him basically a good implementation and put together a lot of the modules, which is a really sensible idea. And somebody made a comment, not naming and shaming here, of, oh, that's going to be a bunch of crap then. They didn't say that. That's my paraphrased interpretation. And Piers' response was, no, it's got a whole load of testing that the AI has written and then has been validated against his real usage. So it is working, and the testing is showing that. AI is very good. Agents are very good at putting things together. They're very good at putting things together that are bad, so you can't trust them exactly. You can trust them to put together tests, but they will test what they've written. That's why you need intelligence behind the scenes, people, and yourselves, not just me, who actually exercise it and go, well, that's wrong. That's clearly not RISC OS, because that happens. It will get things wrong. We only have to look back about 9 months or so, well, maybe a little bit longer than that, might have to do over a year now, and see the rule release of the resolver that had foolishly embedded a Unix path name in it, presumably because it got left behind and the conditional got lost. And that was human error. Human error produces bugs just as well. And had that code had some testing sitting alongside it to make sure it would work before they shipped it, it wouldn't be an issue. But that wasn't the case. So testing absolutely should be there. You should have testing on all parts of your system. And RISC OS Pyromaniac has lots of tests. which can validate that things work, and we can then plumb them into 64-bit as well. So that becomes another big advantage, and it's not something that is special to the stuff I've been doing. I have been saying for many years that we should have automated testing on things. One of the things we put together at RISC OS Limited was automated builds every night, and then we could go and test them in the morning. Yes, that's what we will have. Wonderful. But that was the process 20 years ago. Now we expect a lot more out of it. We expect automated reviews. We expect automated testing. We expect pull request gates to make sure that you can't get something through if it doesn't meet certain quality requirements, where quality might be passing its tests. It might be not having bad code in there that could cause problems, security issues, because security issues are almost certainly going to cause you crashes and failures and the like. Memory problems, all of these things should be tested. So, Pyromaniac has a lot of tests. I'm sure that there are tests that are run on the RISC OS ROMs, but if I can get to where I was, where is this project? RISC OS test. What's it called? It was the tests for RISC OS 5. I know where it is. It's Intel projects. This is why you need a logical structure and not dump things inside things. Test rule ROMs. There we go. This shouldn't be in here. This shouldn't be in this directory. This is something I threw together Friday night. Yeah, I think it was Friday night. And it's not difficult. Yeah, DOSFS got broken. I mean, that's a typical example. DOSFS was broken. That's why I did this. That's what was going on. Thank you for the reminder. Yes, so I saw the posts about DOSFS being broken, and it made me think, well, there should be some tests for this. So I threw some together. Now, I wouldn't actually have exercised DOSFS, but I want to get to the point where that is a possible thing for us to do. So, what do we do with this? So this is a test program here. Test rom.sh. So what this will do is it will obtain the ROM, boot it, and run some tests. So what we do is we go and grab the latest ROM, which is the one that was built yesterday or today or whatever, and we extract the files. We then have this script here that goes and does some manipulation of things and does some magic, and then we go and boot it. And we've got some special code that goes and excludes certain modules because we can't run the hardware on Pyromaniac, but we can run the rest of the ROM. And we run the boot with some extra debugging. We run the modules and get ROM modules out of it. We then do a special build here that does magic to make sure that we can save out RisourceFS. And then we run a basic program using the RisourceFS that we got. So let us do this. Actually, let me just look at this directory. So if I just pull this up here, because this is going to take a little while to run, because it takes a little while to run. But I'll start it running. So test ROM. So we're fetching the ROM. We're now running a test already to boot things. We'll just leave that running. That's fine. If we have a look in results here, we've got some test results from 606. Oh, hang on, let me just do a refresh on this because there should be another folder. Yep, here we go. There's a result from today. So this is yesterday's results. And if we have a look in here, we've got resources. That's the extracted version of RisourceFS. So that was extracted by running the ROM and then running the Pyromaniac version of RisourceFS and extracting all the files out of it. And then we've got the ROM itself, which is this, which unsurprisingly is a ROM. And we've got a configuration file, which looks like this. So this says, particular bit of debug. Here's the extension ROM we're using, the RISC OS Open ROM. Our standard ROM, Pyromaniac ROM, lives in one place. There are a number of modules that get unplugged because they don't work with the current system. Most of them are hardware or sprite related. Yeah, there's quite a few there. You can see there's a few. We put the reset banner on so we can see when we've booted. We'll allow zero page to be enabled. 1. That's interesting. Will abort if you try to write to to low memory or to 0 page, but will allow reads just for the heck of it. You can't. That will allow access to no watching, no reports from low vectors. We don't want interrupts because things go bad, and we'll just write things to output. Because we need it, we'll also include the OSWISE module, which is the RISC OS 5 one, RISC OS select one. There we go, it's finished doing the boot for this version. So actually what we'll do is we'll have a look in here and have a look at the boot log for the current ROM. So this is the ROM that was built yesterday. And this is the log we get out of it. We get to see that here's the RISC OS Pyromaniac ROMs starting up, and here's the rest of the system. So there's a bunch of components here that are all starting up. Many of which are, these are all the Pyromaniac ones, and then we get to the end of the Pyromaniac ones, and then we see the main ROMs. So here we go, this is the Podule ROMs, this is RISC OS 5, that module is unplugged, File Switch has started up, Resource FS has started up. Inside the message trans module, there's a call to read monotonic time. Although actually, it looks like it was actually in File Switch. Whilst message trans was starting up, File Switch got that message. Very weird, but okay. And there's the code that leads up to it that was executed. All the way down here, we've got more modules starting up. There's a bug here. So Window Manager is creating a dynamic area called Clipboard Workspace, which has a control terminator on it, which is not the API. And there's the code that leads up to that. There's a call here that provides a sprite area of 0. I'm not convinced by that because that doesn't look like it's actually a sprite area of 0. I think that's a bug on my side. There's an error report here that tries to return a stupid pointer, and so we generate a warning about that and silently ignore it. We come down here, it looks for sprite mode 15, which is a special RISC OS 5 sprite mode. Fair enough. And then we look down here, we've got more things, booting, inverse table, international keyboard, blah, 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 lots of things. No problems. Couldn't find its template file. Not sure why that is, but it's an odd thing. Don't know. Down here we've got some more things. Freeway, blah, 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 blah. More things started. Gadgets registered. Here's toolbox starting up. Message token not found. Not sure why that is. Not going to worry. Lots of close files. Very interesting that we get lots of close files there. That's whilst what module is starting up there? CDFS. So that's probably because CDFS went and reinitialized a whole load of modules because it's evil. It's not the way it should work. That's really not a RISC OS way. It should be issuing a service to say, reinitialize yourselves, I have arrived. But yeah. Same goes here for Unsqueeze AF has done this. Oh no, this is because ROM initialization started up. So this is where callbacks are being triggered. And we're getting a whole bunch of extra services happening. And then the system was booted. And as you can see, it didn't abort. It didn't have any problems. But it didn't exercise anything either. Didn't actually do any real work. Well, it did. It booted. That's a pretty significant bit of work. We've also got this one, which is the modules being initialized. So the modules list. So this is ignoring most of that debug at the beginning and just doing a star ROM modules. So here we go. There's ROM modules, system ROM, and the extension 1.1 is the actual RISC OS 5 ROM. So there you go. You can see all the modules there started up, and some of them went dormant. So you can actually have a look at which ones are problem. I think Internet and Resolver, I think I've disabled those because there's something up with them. But yeah. It's currently doing the resource FS extract. So if we have a look in there. Nah, it's not there yet. It's probably still in the middle of booting. So each one of these has to boot the OS a whole new time. Attempt to unprotect region of the I don't know what that is. There's something weird going on, but it's a heat protection problem. So it probably is a real issue. Not sure what it is an issue of, but it's probably a real issue. So either it's crashed or no, I don't know. Anyway, so this is the test that I've again knocked together in about an hour and a half or so, that just try and exercise the ROM. Once it gets past the ResFS extract, it then goes into running a simple test. And the simple test we run is this program. Star help star.resources : $. We try and do that. And if we have a look in the simple test log from yesterday, there we are. Again, this has got the warnings at the beginning that we expect. And then we've run basic and we've got star help working, and we can catalog a directory. So those are actually running commands that are inside RISC OS Pyromaniac. But part of the point was to prove that we've actually got working basic on the system. We can introduce more tests here and actually call different SWIs and maybe do other operating calls to see what is broken. So it would potentially be useful to try and test out DOSFS and see whether DOSFS could mount a virtual disk, and see whether it could write to it and things, and whether it was corrupt afterwards. That would be a good example of doing some regression testing to make sure it never happens again. This is the sort of thing that should be done as part of 64-bitting the OS. It should have been done as part of the 32-bitting, but it definitely should be done as part of the 64-bitting, because then we've got example code and example tests that we can use to cross-check that the 64-bit version and the 32-bit version are working the same way. And of course that the RISC OS Pyromaniac version is working the same way, and Merlin's version and Simon's version all can be made to check themselves by having standardized tests. So that is one of the big things that should be focused on, that is not specific to 64-bit but is required as part of that work. Yes, I've got very, very worked up and the like with that. So I hope that has given you some sort of ideas of what I'd like to be doing. What I should also do is have a look at the forums and see whether anybody has actually posted anything else to say, questions on here. Nope, nobody has. So that is all of the Q&As, all of Q's anyway, and I hope I've given the A's for the things we're doing. Right. Anything else people wanted to ask to understand and things? The other thing about that testing is I threw that together in an hour and a half. That's all it took. So presumably other people could have done that as well. It's not rocket science. Yeah. Right. I'm glad it's been informative. Nitrex says it's impressive. RISC OS Tech says it's been really informative. What I shall try and do is thanks for answering the questions, says Martin. You're welcome. I'm happy to answer people's questions all the time. I'm going to call it a day here. I will go and try to generate a transcript, since somebody was asking about that. What I might try and do is I might try and feed the transcript of what was said into an AI and try and make it into a, can you please turn this into blocked questions and answers, and hopefully it will give a good set of descriptions of that. I don't know that it will, but it would be really interesting to see what comes out of it. I would be really interested anyway. Yeah. So with a virtual Gerph, I automate myself into a thing. I mean, the other thing that would be quite nice is if I could make it do it all in my style of talking as well. Yeah, that'd be kind of fun. Right. I am tired now. I'm gonna, wrap it up now. If anybody has any other questions, do feel free to drop them onto the live coding Q&A forum question. You can always, ow, that hurts. It's always good when you've got pains in your chest. This is part of getting old. Feel free to drop them on there. Feel free to drop me an email if you want answers to particular questions. Rob Andrews already gone and had a nap because he was up very late. He was on Australian time, so he would have been like starting at 1 or 2 p.m. I think, 2 a.m. sorry. But I think he just wanted to pop along to say hi, which is nice. Yeah, I will try and do that. I will try and update the configuration so we get closed captions next time around. Oh, also important, I am not doing a session next week, and I am probably not doing one the week after. I may do one if I'm feeling particularly energetic, but I will have just come back from holiday and I probably won't be. If people want to bundle questions together or ideas and the like, then please feel free to do so. I'll be happy to try to answer things. That ResourceFS extract is still running. I don't think that's working. I think it's gone unhappy. I think it's got unhappy on that. I don't know how it got unhappy, but it's almost certainly not doing what it's meant to be doing. So automated testing, it's great, but you've got to also test it. Test the things you're testing. It's only a week off really, but it just happens to end up over the weekends. But yes, I will be taking my time. I'm sorry, you'll just have to. Maybe you can encourage somebody else to do some live coding. Maybe you could try doing some yourself. I would say it's not hard, but it's definitely a thing that you need to be committed to. I enjoy it. I do enjoy it. Right. Thank you all for watching. I am now going to go and find probably a lunch. Actually, that's what we're going to do. We're going to find some lunch. I've just realised that other feeling in my tummy is hunger. So yeah, we'll be doing that. Enjoy your weekends. As I say, we'll try and sort out transcripty bits, and hopefully we'll get something useful out of it at the end. Right. See you later. Have a good week. Bye. Oh, what's the thing you say? Like and subscribe, and maybe do the sponsorship if you haven't already. And I know some of you have, so please don't stress. Thank you very much to the people. Oh yes, thank you very much to the people who have sponsored me, and the people that did sponsor me also got a newsletter with a little bit more information on some things. Nothing particularly greater than what everybody else got, but just as a little thank you to them, there was some extra words, especially to those people. So thank you very much. See you later. Bye.